I'm excited to welcome my colleague Jeff Hatzel, a product manager here at Blue Marble Geographics. Today, Jeff is presenting on advanced point cloud analysis in Global Mapper Pro. Good morning, Jeff. How are you this morning?
Good morning. Are you guys seeing and hearing me?
Yes.
We can see you, and I'm going to give you the screen, my friend. How are you today?
Thank you. Good. You beat me just in time. I thought I was going 10 minutes later, and I was like, I should get on early.
Good.
So that worked out perfectly. Are you guys seeing my? You might be seeing yourselves right now until I switch to my PowerPoint.
We see your PowerPoint. Please take
Wonderful.
it away. Thank you.
All righty. Yeah. Thank you guys for having me back. I always love being on GeoTalks. And it looks like, here we go. So today I'm going to be talking about point cloud and LiDAR analysis in Global Mapper. Specifically, we'll look at some new things, but I thought that, it might be interesting to talk a little bit about how this has evolved over the years in Global Mapper. We'll then talk about some of the newest updates, and I'll pop open Global Mapper for those of you who have seen me talk before. I like to kind of go through things live, or at least semi-live, and kind of talk about how I think it's best to use some of these new tools. So the Lidar module was first released with Global Mapper back at version 15. So we're going on like a decade old now. And that's, a couple years even before I started. And when I was putting together this talk, I was thinking to, even back then when I was new to Blue Marble, new to LiDAR and point cloud analysis, I thought how full and how complete and how interesting the LiDAR module was, right? We had these advanced 3D and profile views. There were already automated classification tools, manual editing, extracting, and all the kind of downstream terrain analysis that you might do after your initial point cloud analysis. And since then, I can think about all the tools that have been added as part of our LiDAR analysis in Global Mapper, right? We now have a variety of advanced QC tools. Profiling and 3D view have expanded not only to handle larger volumes of data, but also in terms of what can be done in those views, selection, editing, manipulating, advanced workflows, right? When we think about point clouds, when we look at one coming up, the idea that it's really important to understand how your point cloud is structured, and that is very easily done by looking at data from different views and different perspectives. And now, today we're going to mention some of the new advanced machine learning based workflows as well. And kind of all along that time, the tool continued to grow and grow. Many of you are also probably familiar with pixels to points. So this is our dedicated photogrammetric analysis tool set, right? You have your drone flight, and then you need to build all your point clouds, meshes, ortho imagery, everything like that. And so this in some ways is kind of the start of a point cloud analysis process. And we added that a couple of years ago to the application, right? Very often, photogrammetric tools are a dedicated software solution that only does photogrammetric analysis. But between hearing from our users and knowing that, very often Global Mapper gets referred to as the Swiss Army knife of GIS, we wanted to expand that functionality and add it to Global Mapper, and we have done so over the years. And as we continue down that road and thinking about all the things that we've added to Global Mapper that were kind of falling into the old LiDAR module, we realized it was time to retire the idea of the LiDAR module and make Global Mapper Pro. And so we'll be looking in Global Mapper Pro today, with the idea being that Pro overall has much more than just LiDAR and point cloud based analysis. Granted, that will be our focus for the remainder of today here. The newest big feature in terms of Global Mapper's LiDAR analysis would be the custom point cloud classification that was introduced with version 25. One of the keys for us being able to do this was the idea that over the past year or so, we had introduced a variety of machine learning classification techniques. We'll look at the different techniques in the app today, but the general idea is that some of these more advanced classification techniques can also be applied to workflows and analytical processes for defining and creating custom classes. So we'll do things like collect training samples, we'll train the custom class, right? So on here, I happen to have airplanes. We're gonna look at something different in a little bit. And then we'll go ahead and classify those custom features as well and see how that turns out. And it's become a really powerful tool because, you know, we have a variety of built-in automatic classifiers, right? I'm sure you're all familiar with classifying ground, buildings, vegetation, power line structures, noise, and things of that nature. But we're starting to see these days as LiDAR advances and we get into photogrammetric point clouds, terrestrial LiDAR, we're seeing a variety of other objects that need to be classified that are very specific and very niche. And rather than, you know, building an automated tool for every single one of those, which would probably be prohibitive in a variety of ways, what we've done is given our users the ability to custom classify those. And so that's some of the new tools that we're going to go ahead and look at here just shortly. You know, for example here, I forgot to move forward, but we'll use this comparison side by side here of the airplane classification, right? The shot on the left shows us a traditionally classified point cloud with all the built-in automatic classifiers. You see our brown ground, our orange buildings, vegetation. You can even see some of the yellow power structures. The result of the custom classification on our airplanes allowed us to identify them as well. You might see some cars off screen here too. I had worked on some cars in this data set and they came out all right too. So a variety of different applications for all of this custom analysis. All right, so let's go ahead and move over to Global Mapper. We're gonna look at a terrestrial-based scan of a bridge and kind of walk through how I analyzed this and why I did what I did, because I think that is the most important part of understanding how we're going to use these tools effectively. Starting with traditional, you know, automated classifiers, then moving on to the goal of custom classifying pillars holding up the bridge. And this happens to be data from one of our users. One of my colleagues shared this with me, and when I saw it, I knew I wanted to feature it because it was such interesting data, and it was, you know, not in-house data that we had gathered or collected or something like that, something that our users might actually be using in the field on their own. And so have to thank Southeastern Surveying for that. But let me go ahead and bring up Global Mapper here. And what we are looking at now is just the point cloud scan in 2D view, colored by RGB. So not all of our point clouds have RGB with them, but this one happens to. And so I find that that really lends itself to helping us understand what's in the point cloud. And we'll certainly go ahead and take a look at all of those advanced tools, but it's so important to look at kind of the boring standard information in our point clouds first. So as we get into that advanced stuff, we do it properly, we do it efficiently, and we get the results I want. And although I call it boring, you know, somewhat jokingly, right? We still, hold on, my window appeared off screen here. We still can go ahead and get this great 3D view of my data set. Let me zoom in here as this loads. I hope this is coming across the stream okay. We have our bridge surface. We have, if we zoom out and look underneath the bridge, we can see the pillars that we're going to go ahead and create. Let's get a little more contrast here. Oh, that looks better. So we're going to go ahead and attempt to classify these pillars and pull them out of our point cloud. I don't see, right, the whole reason I'm doing this is just to get an initial look at my data. I don't see anything that stands out to me. There's a couple little noise points, nothing crazy there. And, you know, we can even see, get to a good zoom level here, where some of those terrestrial scanners sat. And you can see that in 2D as well. Let me zoom out. Get a good zoom level here. All right, we can see those circles. Anytime you see those faint circles, it's a good indicator it's a terrestrial scan. That's important because it tells us we're probably going to have better representation of features on the ground. Whereas if this was something like a dense forest or a downtown with a lot of high buildings, we probably wouldn't expect to get the tops of those features. So it just helps inform us kind of how we want to go about our process of working with this data. I also am a very, very big fan of, let me just go ahead and hide my browser here because I'm seeing myself. What I'm a very big fan of is using profiling to understand my data. And so I'm going to go ahead and just draw a quick profile across my data set. And let me bring that on screen here for you all to see. And what this does is it gives us a great perspective of looking at our data in a profile, in a cross section essentially. I can see my bridge top of my bridge structure. I can see my pillars very cleanly. Again, this helps inform me the data seems to be very clean. I don't have a ton of noise or outliers around any of my features of interest. And maybe I'll do that in one other spot too. Let's go ahead and look along the pillars. Here's another great shot, right? I can see those pillars clearly. This is probably over water, given all the rocks down here by my cursor. Bridge surface, maybe top of the railing or something like that. And we're going to come back to looking at the profile view in a second here. I always recommend taking a look at a point cloud's metadata. This is pretty obviously, right, very high density, so we don't have really any concerns there, but you can always take a look and see just to make sure. If we're talking about really sparse data, sometimes the more advanced classification methods don't work as well, but not a problem here. You can also look at your statistics, things like the returns that we have in the point cloud. You'll see I already classified this, so we don't have to sit around and wait for it to run live. So you'll see that report here of what has already been classified. Once I'm at a point where I feel like it's time to move forward into some of the automated tools, the first thing I like to do is just give everything a quick run through the default automated classification methods that are built into the application. So the automatic point cloud analysis tool is where I'd want to do that. And for those of you who have been with Global Mapper for a long time, this will look a little different to you. Effectively, what we have done is we have taken settings that were shared across 3 tools and put them into one. So we're not constantly kind of repeating and moving between tools. As usual, the layers you want to work with, this is only going to show point clouds, right? So I'm not seeing my base map imagery here. I probably don't even need that. This top section is all of our shared parameters that would be used for both classification and if we were doing any feature extraction today, they would be here as well, right? We're not going to do those, so we can go ahead and minimize those. We will come back to our custom classes here in a second. And then, so what I did earlier was I classified ground, vegetation, and I did some polls as well. And you'll see that the tool's going to say, hey, you've got these enabled to classify. Make sure you set their shared in their general settings. So these settings are things that are going to pertain to a specific point cloud. So you might be adjusting, we don't need to do buildings today, but maybe you're adjusting tree parameters, or you have certain structure of your power poles you're trying to find. Any of these are going to apply to any classification and extraction process. So it's always good to adjust them based on the parameters of your point cloud. And you might say to me, how do I know that? Well, we looked in profile and 3D view. Maybe you took a few measurements. Maybe you have data from in the field, right? That's all data you're gonna gather and be aware of in your point cloud. When it comes to classification, then all of our classifiers, or nearly all of them, have multiple methods. And you'll see right now, I use the maximum likelihood methods. Those are our newer machine learning methods that are based on semantic segmentation. And we'll see what segmentation looks like, but the general idea of it is that it allows us to identify smaller subsets of objects. Rather than thinking of identifying a building roof, it says, here is one roof plane and here's the other roof plane. let's merge them because we know that makes up an entire roof. There's an option for those of you who want to get into the really advanced settings that gets into the segmentation itself. What that allows us to do is expand upon and get even more fine grained than some of the settings provided at the top. This allows us to specify how we're looking at certain features, and it becomes really important when we're doing custom classification because we assume that our custom objects have a very unique signature to them, we can call it. And so you might be defining the structure of what that feature may look like, or some of its attributes, right? Its intensity, its color, think white paint stripes on a black runway at an airport, or curvature, intensity value. We're pretty familiar with the intensity of the return from the sensor when the data was gathered. So you have the ability to really dig in here and customize those parameters to your liking. Once that's done, a simple classify features will run the classification process. Again, I did this earlier, so we're not going to sit through the process again here, but a new thing to note that when you're using multiple classes at once, the tool will properly iterate through so that you can set everything and run it. You know, previously we'd do our ground or maybe our noise, then our buildings and our vegetation, et cetera, et cetera. The tool handles all of that, so it's set it, click it, run it. So you're not moving between different types of automatic classification, which is really handy when you're getting into a detailed workflow. So let's go ahead and pretend here while I was talking, the classifier ran, and we'll color our data set by classification. We'll hide some of the stuff that I don't want to look at yet. We can see our ground, can see some of our vegetation that was on the median of the road. Our poles were classified as well. And there's still some unclassified data that's probably under the bridge. We'll take a look at that 3D because that was the stuff I saved to do some custom work on. But overall, the point cloud has, and we'll maybe come to this side too, right? We've captured the vast majority of the structure of the data set. Now I'm ready to move on to thinking about what does segmentation allow me to do in terms of custom classifying and identifying those bridge pillars. Now, the first thing I do in this scenario, we're going to go back to look at this by color. Or actually, let's look at it by elevation. The first thing that I like to do is simply go ahead and take a look at this feature in 3D space. I'm going to zoom in here underneath the pillar. Right? All of these pillars to me look very symmetrical. I don't see any extreme variation between them, and they all look really well represented in terms of density, right? There's not a lot of missing points, of holes in the data. We've even got somebody maybe fishing or surveying over here. But so really good, solid, clean representation of what the object is that I'm trying to identify. I also took some measurements. Actually, I prefer to do that in the profile view, but it's a totally valid workflow to do in the 3D space. But we can use some measure tools to take some basic measurements of my structure and understand their size and their dimensions, so I get a feel for what they might look like. So when the time comes, what I did was set up custom segmentation. And effectively think of this as the intermediate step to what would normally be an automated classification process. So this happens under the hood, is then used in our automatic classifiers. Or what we do now is we run it manually, and it gives us segments on our data. So if we take a look at that, and I'll color my point cloud by segment, we see a lot of wild colors, and each of those colors is its own segment. Segmentation, generally speaking, you'll do it for a certain feature, right? So the bridge surface here probably isn't going to get segmented because it's so different from pillars that it's not going to apply to those custom settings I just set. So that's an expected outcome. But what's really exciting about this data is looking at, I remember the first time I ran this and looking at how well we were able to identify the pillars, right? Each pillar looks incredibly clean. We have more or less no real gaps in them, maybe a little noise, but that's so minuscule, it doesn't matter at all for any of our downstream workflows. And so I can very clearly say, oh, each of these segments looks like the pillar as I want it to be. As an example, right, so I wasn't targeting vegetation here at all. Look at how noisy the vegetation or maybe even the rocks are, right? That is not my target. If my pillars were as colorful as those rocks, it would lead me to think I probably want to come back and readjust my settings here. So what I'm going to do now, I'm feeling confident in the segments that I have set. I'm going to go ahead and enable custom classification. Let's zoom in here. So what that does is it allows me to collect training samples, and it also allows me to create a custom class. So I'm going to do that first, and we'll call this pillars. That might reset my old pillars, but that's okay. And then a variety of ways to select the data that you want to work with. I am a big fan of using the selection by segment tool, and go ahead and zoom in. And what I'm doing is just collecting a couple samples. So I'm going to collect this segment, my pillar, and I'll add it to my pillar class that I'm creating. If you're curious, you can see and adjust all of the statistical parameters that define the specific pillar. So I'm going to do it for just a couple. Make sure that I add it to the proper class, and I'll do one more here just to show what that looks like. Oop, I added that to the wrong class, so let's adjust that. So at this point, I have my samples. We'll zoom out. We can see that one's selected, right? I have my samples. They are added as training samples. Then all I need to do is train based on it. Once that happens, we'll see that I've now defined statistical parameters as to what I expect all pillars to look like. And that is what the classifier is going to use when I choose to go ahead and classify those pillars. We do want to make sure that we have ground classified before we do any other custom classification. So make sure you've done that first. Another reason I like to do that first. You can go ahead and classify those pillars, and we'll take a look at that output here as well. I know I'm going through that a little quickly, but I have a couple other things I want to talk about in my last few minutes. So we'll go ahead and take a look at what that output looks like. And you may have seen that already. Let me clear my selection. So you'll notice probably two things here, right? We can see our pillars from top down. Most of them look pretty well identified. Let's go ahead and look at them in the 3D space. And we'll get under the bridge, and we're looking at just a subset of the data, but look how clear those pillars got classified. Now we're seeing them all as the same color because we're visualizing our data by classification, and I had previously made these purple. You can adjust all of that. We didn't take a look at that now, but that's just a setting to adjust the color and the name of those custom classes. So all of those pillars look really good. Now, when I was segmenting this earlier, I went a little bit beyond it just to see what I could do. So let's look at the segment again. And we'll take a look. Is this a good? Yes. Take a look under the bridge here. In addition to the pillars, we got very clean segments along what I called the cross beam. I do not know the specific architectural term for this portion of a bridge, but I got very clean segments along those as well. And so I had previously created a custom class for those, and that is why here, let's go ahead and dock our profile view or our 3D view. And so that's why when I color by classification, we also see that those portions of the structure are classified as well. Now, I didn't put a ton of effort into this, right? This came out of my goal of the pillars. So you could argue, maybe that's not perfect up there. What would you do with this since it's not a full structure in the scan, right? They didn't get the whole side of the structure. Again, not the goal of the specific workflow, but a really good demonstration of the power of what that tool allows us to do, even if it was a bit unintentional. And you know what, we're gonna try something here. It looks like I have a couple minutes left. We're gonna try something that I thought of earlier, but didn't look at previously. So one of the things that comes up when we have custom classes often is someone says, great, I can see them, I can identify them, I can count them, I can do whatever. But let's say I need to model that and I need to show it to someone, or I need to put it into another software or use it in, X, Y, or Z scenario. What we're going to try to do here and hope it works is go ahead and make a mesh or a 3D model out of these pillars and see what those look like, because Global Mapper will not only render those, but it will allow us to export them as well. So I'm going to go ahead and just select a subset of the pillars since I don't quite know how this will go. So let's just go ahead and grab 3 of them. And we have a tool in Global Mapper that allows us to create a 3D mesh from a point cloud. And that's very similar to, for those of you who do photogrammetry, that's part of the photogrammetric process. In this case, it's a traditional LiDAR, so you're just effectively making the mesh from that point cloud. So that tool allows us a variety of ways to create our meshes without getting into the details here. We're just going to do that based on our selected features and cross our fingers and see what we get. So in this case, let's see here, since our point cloud does have RGB, our pillar meshes in theory should also have RGB. We've gotten some features and they will look much better in 3D, hopefully. So, looks like they've gotten the color. Let's brighten this up a little bit. And there we go. Now we have a 3D model of those pillars. They look rather green. Oftentimes with terrestrial LiDAR, you'll get color from like a different object. It could very well be greeny and algae under the bridge, but oftentimes if your scan travels up a little, you get some green from trees or something like that. Or sometimes you'll see your power lines are sky colored and stuff like that. But that came out actually really well. And so now this is a full, 3D mesh feature of our pillars here. And this could be used really however you wanted. You could export it to any of the supported 3D model formats, OBJ, FBX, STL, any of those. You could use that in maybe a further process in Global Mapper. Maybe you're going to be bringing in terrain and you want to sit your model of your custom classified feature on your terrain, whatever the case may be. So really, really opens up kind of what the next step workflows are. Because if we think back to the beginning, we started with an unclassified point cloud and no built-in way to classify our bridge pillars, but using some of that advanced custom classification, geometric segmentation, and some of those machine learning methods allows us to very quickly go ahead and identify features of that nature. But I think that pretty much wraps me up with where I wanted to get to today. Hope I haven't run too long. I think it's been just about a half hour. Happy to answer any questions if any came in, Meg or Cynthia, if you guys are around still.
Yes, thank you, Jeff. That was an amazing presentation. I learned quite a bit just from watching you. We do have a few questions for you here, and I think we have time perhaps to answer all of them. So the first one, how do you clean your data and remove noise during classification in your point cloud data? Do you want your screen back?
If I can have the screen back, sure, but it's an easy one to talk about. So I did skip over that a little bit, and actually just because I didn't think I'd have the time to discuss it. But this data was very noisy early on. It was really actually quite cool. Because so the terrestrial scans on the bridge, right? They picked up all the cars, but the cars are moving fast, the scan's moving fast. So we had all these streaky lines right above the bridge surface, and I just had to get rid of it because it was too much to work with, to look at. So the automatic classification tools have a variety of options for classifying noise. You can do that automatically, and you'll see there is some in this point cloud that I had left on. If we look at it in the 3D space here, some of these red points that you see down here, those are some noise points that I left on so we could see them. You can do that automatically. I'm also a fan of, in a data set like this, right, it's not large. Use the profiling tool, use some of the variety of selection tools. Let's say I'm going to call this noise, right? Maybe everything right here. And then click and call it noise and manually do it that way. If it's a quick little cleanup like that, you can do that as well. So there's a whole bunch of different ways to do it, kind of depending on the data you work with, the amount of effort you want to put in, et cetera, et cetera.
Awesome. I do have quite a few others, but I think we still have a few minutes. Yeah, you do have a few minutes. So the next one is roads along a least cost have width. So how would they be used? How would you use the polygonal geometry to come up with the least cost for a road, considering the width?
Okay, a little bit outside of this specific topic, but generally speaking, least cost path looks straight along a given path. And hold on, let me pull that open here. Let's see if we can look at it so I don't have to talk without. I'm going to go ahead and make a quick terrain grid here. It will not look pretty, but it will give us something to work with to answer this question. Generally speaking, this follows along a given line between 2 points, and it does so at the pixel resolution. So right now there's no way to do that along the width of the road, but if you need to do something like that, I would assume that what you'd want to do is to probably set, if you have a road area feature, I would use a custom site plan tool rather than least cost path, because once you connect the points, you could use that area feature and figure out the best placement within that path, and that will allow you to place the road feature in a way that minimizes the amount of cut and fill that you would need to do. So it'd be kind of a combination of two tools there. Sorry, I don't have a more succinct answer right off the top of my head. I was not in least cost path mode, but that's how I would go about doing that.
All right, so sorry, just looking here. There are so many. They're coming in fast. So when using the optimized pad location tool, can you give the pad a cross slope of 2 or 3% if desired?
Oh, let's see, another good off the topic question here. Let me find that tool here quickly. Turn out no, is that I also don't have here. Let's do it this way. So I'm just throwing on some reference data here for anybody who wants to look at it. I think there was a talk on this earlier that is what is being referred to. And so I'm just trying to catch up on that since I didn't have my brain ready in that mode. I'm just trying to find it. Go. So the question was, I think, slope across the feature, and that would kind of go against the idea that this tool is designed to find the minimal placement of the feature based on cut and fill. And I would think if you wanted a slope of that regard, you'd probably want to define the feature first, and your feature could be a 3D vector, which could have the slope defined to it, and then use that as your starting point. But I don't think that would be appropriate for a general site placement optimization.
Awesome. And the last question for today, because we are running out of time now, is perhaps it's a simple one. Why does the cut and fill process has 2 steps?
I think without a little more context there, I'm not quite sure what that question's getting at.
Okay.
Yeah, I would ask that question, have them send that into our support channel. I'm sure you've talked about that today.
Yeah, I'll send that to the support
I would have that sent
channel.
in with a little more detail, because that could mean a couple things. So rather than.
Okay, sounds good. So
Yep.
can I ask then another one? So how long does it usually take to collect enough samples to train a classification?
Good question. So while I was working on this and fooling with it, you know, from just starting to look at the data, the whole entire process to what you saw today was maybe an hour. In terms of the samples themselves, though, once you've segmented the point cloud and you're happy with that, it's literally the click that you saw me do on screen. It's click to select it, add it as a sample, collect a couple, run the training. The training takes, you know, on the scale of minutes, not a half hour, hour, et cetera. So it's not a long process. It's not, you know, something you're going to run overnight or anything like that in terms of the actual collecting the sample and training on it. It's a relatively quick process.
Awesome. Well, Jeff, that wraps it up for us today. Thank you so much for joining us, and appreciate all the information you shared with us. This was exciting.
All right, take care.
All right, thank you.